The PDO turns the most negative ever. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, August 3rd. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype. If you enjoy the video, give us a thumbs up. If you haven't subscribed, please click the Stormsurf icon down in the lower right-hand corner of your screen. Get you all signed up there. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below. The heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Our predicament, Evolution Moto, Tim Caston, B. Nadine, Elliot Harris, Mont the Drifter, and Leona Noni Roberts. Almost all these people are longtime contributors. I really appreciate your ongoing contribution. It makes this channel possible. And now, with that, let's get to work. We'll start off looking at significant wave heights around the planet. In the North Pacific, a series of tropical systems. You can literally see them rotating around high pressure that's over the North Pacific. 1, 2, sort of 3 and 4 there. So none of them particularly interesting in terms of storm or swell development, but at least there is some activity there. In the South Pacific, 1, 2, 3 gales, inflow, max seas about 31 feet right here, highest seas over the entire domain right in that area, aimed at South America. In the North Atlantic, as would be expected, pretty quiet pattern. There's some low pressure here trying to develop off the outer banks. That might produce some surf finally for surf-starved breaks along the U.S. East Coast. In the South Atlantic, 1, 2 different gales, sea heights in about the 26, 27-foot range, producing surf targeting mainly South Africa. And then in the Indian Ocean, another gale with 31-foot seas, another with 26-foot seas, all helping to feed the continual swell production machine in the Indian Ocean. But before we get into all that, let's take a look at current conditions. We're going to start up in the Pacific Northwest, Grays Harbor, Washington, buoy number 036, off the border there between Oregon and Washington. We're looking at all the energy that's hitting that buoy, all the way up from 13.3 second period, very long period energy, which there is none, down to 5 second period, just pure wind chop. We see a peak of energy here at about 18 seconds and another in about the 6 second period range, so wind chop. Using the algorithm, we'll see how well this does. Primary swell, 1.1 feet at 18.4 seconds from 232 degrees. That's southern hemi swell. It's starting to hit there, producing surf at about 2 feet. And then the wind swell, 2.9 feet at 6.3 seconds from 306 degrees. Producing surf at about 1.8 feet. Next, we go down to Central California, Point Sur buoy, number 157 there, south of Monterey Bay, just south of there. Again, looking at the energy profile, 16 second period energy, another bit of 13 second period energy, and some 7.1 second period wind swell. Let's see how the algorithm does. Primary swell, 4.4 feet at 16.4 seconds. From 317 degrees. Secondary swell, making surf at about 2.8 feet. Then secondary swell, 1.9 feet at 14.9 seconds from 188 degrees, making surf at about 2.8 feet again. So primarily mixture of northwest wind swell and southern hemi swell. Then we head down south to Southern California, the Point Loma South buoy, buoy number 191. Again, the same sort of profile, 16.7 second period southern hemi swell, a little bit of other tropical swell mixed in, and wind swell. Let's see how the algorithm does. Primary swell, 1.7 feet at 16 seconds from 200 degrees, producing surf at about 2.7 feet. That's about right from what I saw looking this morning. Secondary swell, 2.6 feet at 10.4 seconds from 190 degrees. That is the tropical swell, somewhere between 10 and 12 seconds, something like that. Also producing surf at 2.7 feet. And then finally off to the Hawaiian Islands, Lanai, the buoy there, number 239. we see energy at 13 seconds. That's fading southern hemiswell. A little bit of building longer period swell underneath that, and then some wind swell. Primary swell 2.1 feet at 12.6 seconds from 179 degrees, making surf at 2.6 feet. With secondary swell 1.9 feet at 9.3 seconds from 179 degrees. That would probably be fading tropical swell, I guess, making surf at about 1.8 feet. So let's go take a deep dive into what's happened over the past week. We're going back to Sunday, the 27th of July, when our last video was produced. In the North Pacific, there was a tropical system south of Japan producing 42.1 foot seas, all aimed off to the north. Put this into motion. That system continued north and basically faded out as we got into Tuesday, the 29th of July. Now notice a pair of tropical systems passed south of the Hawaiian Islands, producing some swell. I think it was mainly for the Big Island, like southeast facing shores and south facing shores. Yeah, but they're tracked purely off to the east. Most of the swell travels in the direction the storms are heading. So it was not a major swell producing event. We're into Thursday. Another tropical system here. It was a tropical storm. We're actually on Thursday, the 31st of July. Formed south of Southern California, built and right about as it was ready to move out of the Southern California swell window on early Friday, the 1st of August. It reached minimal hurricane status. Swell from that system started hitting exposed breaks in Southern California this morning. Nothing huge, but rideable. I think it was like 2.5 feet at 13 seconds or something like that. And then moving on out, more tropical activity off of Japan. None of it really. This shows it recurving. Theoretically, there could be swell from this, but I'd say the odds are extremely low just based on the sea heights, and models probably overestimating what they actually are. Now, here's where the real action was. We're going back even further to Thursday, the 24th of July, because a gale started developing south of New Zealand right there with 33-foot seas building to 34, 35, 37 feet. That was the peak of it right there. And then 36 feet. We're into Friday morning, all lifting due north. Swell has already passed the Hawaiian Islands, but it is the southern hemiswell that is hitting California as we speak. Now notice most of this activity, and I'll sort of run through this really quick here, was all aimed due north, targeting Tahiti and the Hawaiian Islands best, only sideband energy into California. And then, of course, that thing faded out about a week ago. Now we're into current time, or not current time, but moving closer. Tuesday, the 29th of July, a new gale developed. Now this further off to the east with 26-foot seas. That was about the peak of it on Tuesday, 29th of July. Swell from that system is pushing north, scheduled into California in the, I think Tuesday, Wednesday time frame. Now, of more interest, we got into Friday. Notice this system built south of New Zealand. That with seas to 40.8 feet. That was on early Thursday morning, the 31st of July. Swell from that is radiating off to the northeast. Another gale developed right behind that with 45-foot seas. These are all in the Southern California swell window. Not so much for Hawaii, but because this has higher seas and stronger winds, the swell will overtake, or at least not join up, but yeah, I'll call it overtake the swell from this system, the two of them hitting at the same time. You can see that. And then yet another system developed right in here on Sunday, the 3rd of August, that is today, into current time. That swell from those two systems are pushing over this area, and yet more additional energy will come into the mix, targeting primarily Hawaii, but also adding sideband energy into California. Now, the point is, will all three of these swells combine to make some big swell? And the answer is no. But they will all be hitting, at least in California, at the same time, making for more consistency, a sort of a spread of directions from, this is anywhere from 212 degrees all the way down to 220 degrees, something like that. So a bit of energy, and with more behind that, we'll look into that in a second, a long run of swell. Maybe not huge, but consistent, longish period, and over an extended duration is expected. Off to the North Atlantic, put this into motion for the past week. Now, given that it's deep in summer, you would expect not a whole lot to be going up in this region, but typically we'd be looking down here for some tropical activity, and there just literally is nothing going on until you get, here we go, something, weak low pressure off of Cape Hatteras. I don't even call it tropical, though I know the Hurricane Center is watching it, looking for possible development. Looking at what's been happening for the past week over the South Atlantic, we'll put this into motion. Little gale developed here with 24, maybe 25-foot seas targeting South Africa. Redeveloped, producing 26.7-foot seas, building to 28 feet. This was on like Wednesday or so. Swell from that and other additional energy has already hit and pretty much passed South Africa. And here we are on Saturday, another system falling south. Yeah, sideband energy. This one, though, that developed Saturday night. Let's actually put this back. Yes, Saturday night into Sunday morning with 26, 27-foot seas targeting Southwest Africa. And we'll see what happens with that. So some degree of swell targeting Africa. And then finally, to the Indian Ocean. The review of the past week, there was a gale with, 39-foot seas that developed a week ago on Sunday, but you saw that right into the ice line in Africa. Also notice the ice line as we go through this. It continues to retreat. Another gale developed on Tuesday, Wednesday, the 30th of July, pushing off to the northeast, but kind of faded out. Lingering remnants of 27-foot seas continue to target Bali, Indonesia, Western Australia. Stronger gale, though, south of that. 40-foot seas on Thursday, the 31st of July. Also notice here's one of the series of gales that pushed under Tasmania, targeting the U.S. East Coast. That gale built with, what do we have? 43-foot seas, 40-foot seas into Friday and Saturday. You can already see swell energy was pushing into Western Australia about 24 hours ago, and is likely, you can see the swell front here, targeting, if not poised to hit Indonesia as we speak. And this is the final frame. Another little gale behind that with 31-foot seas. We'll see what it's supposed to do as we get deeper into tonight's presentation. So let's take a dive into the South Pacific. We're going to get into what is happening starting. This is the forecast going out the week, detailed forecast for the South Pacific. We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. And when those gales form, help direct their track. We're looking for a trough, a push in the jet to the north. You can see that right like sliding up there. This is the northern branch of the jet, the southern branch, the two of them, at least for a little bit, interconnect. I'd call this more of a cutoff trough. Anyway, that is a trough, a push to the jet. And what troughs do is help create a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface and impart energy to the ocean, creating seas. The stronger the winds, the higher the seas. Those seas eventually radiate or propagate away from the fetch area. The shorter period elements disappear, and the longer period elements of the swell, what we commonly call ground swell, evolve and eventually hit your beach, creating surf. But it all starts with a trough in the jet stream, and we have one right here east of New Zealand with winds 150 knots feeding it, offering support for gale development. But just east of there, in the I'll call it more the southeast Pacific, jet is doing the exact opposite, falling hard south. That creates high pressure north of it and does nothing to support gale formation. We have another little trough, but not a whole lot of wind energy pushing up into it off of Patagonia, perhaps supporting swell development for Chile and Peru. Let's put this into motion now, see what's going to happen over the next week. Okay, this trough continues, but you see it getting more and more cut off as we get into Monday and Tuesday, and then that's pretty much the end of that. The trough off of Patagonia pushes inland, or if nothing else, is very cut off, and then things kind of fall apart. Notice there is a little bit of a trough here south or north of Antarctica, but the ice line is about at 63, and it's whatever fetch it's going to produce will all be over Antarctic ice. That does nothing for us. Now, fortunately, as we get into Friday, the 8th of August, here is a nice trough pushing north of the ice line, being fed by 130 knot winds, if this plays out as forecast, supportive of gale development. So that'd be on Friday, the 8th of January. Winds build to 150 knots as we get into Saturday, so even more support there while lifting off to the northeast. And then finally that trough fades out as we get into Sunday. We're now a week out, and we end up with basically a zonal flow, the ice line right about here, right where the jet's flowing, probably offering not a whole lot after that. The jet stream is the foundation of the storm production machine, but it actually takes winds blowing on the ocean surface. And we have two gales as expected based on the trough pattern. One off of Chile producing 35 to 40 knot winds aimed well at the coast right in here. And then we have that other broader one with winds to 45 knots aimed off due to the north, Buoy at 158 west, so due north of this system. Tahiti about 140 and 20 something, so right in this area. Sideband energy, but probably not on the direct path. So this would be, at a minimum, a Hawaii swell production event. You see the winds continue into Sunday night and Monday, offering opportunity there, and then that gale, the trough, just cuts off, and that's the end of that. Now another system is forecast trying to push under New Zealand. Wind's not really strong enough, 35 knots. This is on Thursday, the 7th of August. And then a broader system with 40 knot winds on Friday, the 8th of August, aimed and pushing off to the northeast, as you see there. Not a giant event, but perhaps offering a modicum of hope, with secondary energy now forecast on Sunday. This is all a week out with 40 knot winds aimed to the north. So we'll have to see what happens with that. But it's kind of interesting. There's just been this persistent trough right in this area with gales producing south winds all aimed well at Hawaii and bypassing the U.S. West Coast. Whereas earlier this summer, it was all aimed at the U.S. West Coast, and Hawaii was completely cut off from the flow. So everyone gets their share of action, it seems. So what effect are those winds having or going to have on the ocean surface? Well, we know we have not a cutoff, but one of those troughs again here in the central South Pacific, producing 28-foot seas aimed off to the north, building theoretically to 31 feet today into 31 feet this evening, and then fading from there. Again, Hawaii, the main target, but you see a little bit of a northeast bend in the winds and the seas as we get later into Monday night, targeting the U.S. West Coast, but probably not the main focus. After that, things settle down. Another bit of energy, the final bit on Friday, the 8th of August. Forecast pushing under New Zealand, producing 31-foot seas, and that's about it, 30 feet, fading out from there, but lifting off to the northeast. So swell potential for Hawaii and California from that. Notice here's that other little fetch that was supposed to develop from that. We'll see. And not really doing a whole lot. And there we're out a week. Don't trust the models even out a week. So we'll see. But there is some more hope. In the North Pacific, the remnants of, I think it's still a tropical storm Gil, targeting now the east shores of mainly the Big Island. Maybe Maui could get a little bit. Maybe even the north shore of Oahu. Or not the north, I call it the east shore of Oahu. Let's try that. And then another system forecast south of that. Let's go back. That would be on like Monday night, Tuesday. Not a particularly strong storm. Doubtful any swell will reach up into Southern California. But this has the potential, again, same sort of track, pushing towards Hawaii, but even weaker than Gil. So not sure about that. And yet another beyond that, South of Cabo doesn't do anything. Something off Japan, we're out almost a week. Again, I don't know if I believe the models on any of this. We'll just have to see how it plays out. But at least there is tropical activity now in the North Pacific. Off to the North Atlantic, again, the main feature here relative to the U.S., little system that's trying to organize off of the Outer Banks. Sea height's not very, 10 or 12 feet, but at least forecast to produce some degree of wind swell targeting back. It's a low pressure, so the north end of the storm is producing east to northeast fetch, targeting this whole area in here. Not big surf, but given what's been happening this entire summer, anything is a godsend compared to where it has been. We're out to 126 hours. We're into Friday, Saturday, and then finally Sunday, and nothing else obvious. Though I did see on the models some sort of a tropical wave possibly pushing north of Puerto Rico in that area out more than a week. Again, I don't believe the models, especially on tropical systems, going out a week, but any bit of hope is a good thing. To the South Atlantic, there is this gale, 26, maybe 27-foot seas targeting South Africa. That continues off while another gale builds behind it on Monday with 32-foot seas, building to 36-foot seas, maybe even 37 feet, holding together pretty well just before it gets close to the southern tip of South Africa. Still 28-foot seas into later Wednesday, swell more than likely for all of Southwest Africa. Put this into motion, see what else happens. Another one behind it with 25-foot seas on Friday. That sort of fades out as we get into Saturday and Sunday, and then pretty calm after that. Off to the Indian Ocean, currently seas 26 feet, impacting the southwestern Australia area. Swell front pushing towards Bali and that area. Another gale with 31 or 2-foot seas pushing south. 29-foot seas pushing south on Monday into Tuesday of southern Australia. Continued stormy pattern, 29-foot seas. Nothing huge, but certainly capable of producing surf we're into Saturday, and then Sunday. Things actually quiet down a little bit. We just take it out to the end of the model run. Maybe something out here in the central South Indian Ocean a week out, but not as strong as the current pattern. Looking to the local wind forecast for California, Hawaii. California here, that'd be Southern California, Central California, San Francisco Bay Area, Northern California, Hawaiian Islands out here. The general sense, you can see high pressure here, producing a gradient, northwest winds along the California coast at 15 to 20 knots, then trades out the Hawaiian Islands at 15 to 20 knots, with tropical low pressure embedded in there, tightening the gradient, producing up to 40-knot winds, targeting the east shores of the Hawaiian Islands on Sunday. That system pretty much fades out as we get into Monday. I wouldn't even call it depression status. NOAA is not either. Northwest winds, 15-20 knots along the California coast. New tropical system supposedly forms as we get into Tuesday, likely reaching hurricane status, but a little bit east of the Southern California swell window. Perhaps, again, it rotates counterclockwise, so maybe some energy off the back of the storm pushing up there. Otherwise, trades 15-20 knots for the California coast. Lighter trade wind regime ahead of whatever's left of this, of what was Gil for the Hawaiian Islands. To get into Wednesday, same sort of drill, 15-20 knot winds for North and Central California. Light northeast trade wind regime for the Hawaiian Islands. Tropical system holding together while pushing off to the east. Thursday, repeat again, a little bit broader area, northwest winds here, probably generating wind swell for exposed north-facing breaks north of Point Conception. Trades build 15 knots for the Hawaiian Islands. Friday, the gradient fades. 30-knot north winds over a tiny area, sort of pushing down the California coast. Light trades ahead of the next tropical system for the Hawaiian Islands. This system forecast to move northeast of the islands. That actually might produce some surf for all northeast-facing shores of the Hawaiian Islands. We're out to Sunday now. really, it holds together pretty nice. So there is potential here if this happens. Another tropical system south of there on Sunday, the 10th of August, but not really doing anything. You can see high pressure clearly in control, but a light wind regime along the California coast. That will give water temperatures a chance to rebound some. They're likely going to take not a huge hit, but a minor hit from northwest winds blowing north of Point Conception, basically, this entire week, but only at 15 knots, maybe 20 knots. That doesn't create a lot of upwelling. That's pretty much standard there. Temperature forecast for the intersection of the Pacific Crest Trail and Tioga Pass Road there in Yosemite Valley. That's up at 8,700 feet. I happened to be there all of the past week. 2 mornings, temperatures got down cold enough for frost, and one of those days a pretty hard frost, so it was 37 degrees for a couple hours right before sunrise sort of thing. Anyway, and that didn't really show up on this, and there was a pretty good thunderstorm. I mean, there was middle of last week, there was good rain activity and thunderstorm right on the very eastern edge of the Sierra. I think it was more up towards the Tahoe area than down in Mammoth and Yosemite area. Anyway, looking out, temperature forecast, here we go, 55 to 60 degrees for Sunday, Monday sort of thing, and then maybe warming up 60 to 65 degrees starting later in the work week on through into the week beyond, so that would be the 12th of August. So surf forecast for a couple of select locations. We'll start same thing as we did before with the current conditions. Columbia River area up there, east or west of Portland. Surf height's pretty small. Let's get this a little higher so you can see the dates here. Sunday into Monday, 1 foot, 1.5 feet. Building wind swell on Wednesday into the 4 foot range. Fading later Thursday into Friday, and then maybe coming up to about the 2 to 3 foot range for next weekend. Winds pretty light, not very strong. Here we go. Swell heights. Well, you see a bit of southern hemiswell, 0.9, 1 foot at 17 to 18 seconds. That's today. Bits of that still hanging on into Tuesday at 1.4 feet at 12 seconds. Otherwise, just basic wind swell. And then up to 4 feet at 10 seconds on Wednesday. This is the bulk of the wind swell into here. That's slowly fading out. Then some more wind swell for next weekend in the 2 to 3 foot range at 10 seconds. Down to Santa Cruz, California. This isn't exactly like any spot in Santa Cruz. It's just a random spot sort of off of Santa Cruz area out in the ocean. Surf heights, 2.5 feet, fading to 1.5 feet as we get into Tuesday. Then you see it start coming up Wednesday into Thursday as southern hemiswell starts to build. Surf heights, 3.5 feet sort of thing, dropping off as we get into the weekend, but then coming up after that as more southern hemiswell hits. Local winds, not too bad. Yeah, you got to deal with Sunday, that's today, and Monday, but after that, a pretty light wind regime. Swell heights, now this doesn't really tell the whole story. 1.2 feet at 16 seconds today. In the 1.1 feet at 15 to 16 seconds on Monday, and fading down into Tuesday. You see the push and pull in the model between what's bigger, the wind swell or the actual southern hemiswell? Then you see more swell start to build on Thursday, 1.6, 1.7 feet at 16 to 17 seconds. 1.7 feet at 14 seconds, and what this doesn't show you, it's all continuing to come in underneath the wind swell. Maybe the southern California chart will show it a bit better. Down to Dana Point, you see small surf, 2 feet sort of thing dropping off as we get into Tuesday. Then surf starts coming up 2 feet, 2.5 feet, 3 feet sort of thing, dropping off as we get into next weekend, but after that, starting to build in earnest. Winds, not an issue. Actual swell heights, well, this is showing mainly the tropical swell, 2 feet at 10.5 seconds sort of thing. That dropping off. Then here comes southern hemiswell as we get into Wednesday, 1.8 feet at 16 seconds, 2 feet at 16 seconds, 2 feet at 14 to 15 seconds, dropping down to 1.8 at 13 seconds. But after that, things to start coming up. There is a whole series of swells already in the water, trying to make the anywhere from 8 to 10 day journey from under Australia up into the U.S. West Coast. South shore of Oahu, surf heights in the 2 to 3 foot range the whole way through the week. Then coming up much bigger as we get into Saturday, theoretically 6 feet, and that would be 6 feet Hawaiian. I think that's probably a bit overstated, and it's some of this thing that I was warning about earlier. When you have multiple overlapping swells, the model will take them, try to add them together like it's a sea state, but long period swells don't add together. If you're a boater, short period swells do, and you get this, it can make for dangerous situation, but a long period swell is a long period swell. They each have their own identity, and they do not merge with each other. They might override and intermix with one another, but they don't build to, create something twice the size of what any one of the individual swells might be. Anyway, so we see surf heights getting bigger as we get into next weekend. Trades pretty much in the normal range. Let's see if we can pull up some swell data here. All right, 1.5 feet at 16 seconds on Monday, 2 feet at 14 to 15 seconds on Tuesday, continuing in the 2.5 foot range at 13 seconds Wednesday, Thursday sort of thing. Then you see things coming up as we get into Saturday, 3.8 feet at 16 seconds. That is a little bit suspicious. Most of that, I think, would be from that the gale that's developing right now, again, aimed due north at the Hawaiian Islands, with then some swell from under Tasmania coming up through the Tasman Sea, working its way up, and some swell wrapping around under New Zealand. So 3 different swells, all hitting pretty much at the same time, going to go on for, in the Hawaiian Islands, probably 5 or 6 days. And down to South Africa, Jeffreys Bay, surf heights building to 15 feet as we get later into Monday and Tuesday, and you see this dropout, 24 feet, and then what that means right there is a whole bunch of wind and probably pretty bad conditions. You see the winds blowing 20 knots. That's actually not too bad. Then you get a better, clearer shot of swell with surf heights theoretically 24 feet into Friday. It will be much less at Jeffreys Bay. That's the grid point that we're anchoring on here is a bit off the coast, so it's kind of overstates it. By the time it gets into the coast, it's something less. You see the wind pattern, a mixture of pushing up the coast, pushing offshore, pushing down the coast, so variable conditions indeed. The swell heights, 11 feet at 13 seconds on late Monday into Tuesday, 16 feet at 14 seconds on Tuesday, but then probably a bunch of wind, not so pleasant. And then beyond that, more organized swell, 14.5 feet at 16 seconds as we get into Friday and Saturday, fading down from there. And then finally, Bali, the catcher's mitt for all swell in the South Indian Ocean without any of the wind effects. Surf heights 12 feet Monday into Tuesday, up to 17 feet on Wednesday. Again, that's probably overstated a bit. Dropping off, building back to 11 feet on Friday, and trickling down from there with some sort of trade winds in the 10 to 15 knots the entire time. Swell heights, 7.8 feet at 16 plus seconds on Monday into Tuesday, up to almost 9 feet at 17 seconds on Wednesday, and holding the way through. Now, this doesn't suggest that there's any dropout, though. Again, this is Bali. Sorry, I was thinking of South Africa, right? So, yes. Pure clean swell, then 6.7 feet at 16 seconds Friday, dropping down from there, but still 4.9 feet at 14.5 seconds. I mean, just continuous, long period, clean groomed swell for the week to come. All right, let's go take a look long term. What's going on with the 2 major weather oscillations that affect the potential for swell development? The MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. And though I don't have it on here, I probably should just put it on this slide. And the PDO, the Pacific Decadal Oscillation, the thing that we were talking about in the title of this video. The setup for all that is coming now. First off, we'll start with the MJO, the Madden-Julian Oscillation. There are 2 phases to it, the active phase and the inactive phase. The active phase is our friend. It is a low-pressure system. The active phase of the MJO takes warm, moist air, lifts it aloft up into the atmosphere. That energy gets caught by the jet stream, invigorates the jet stream, makes it stronger, helps dig out troughs, which then in turn produce storms, gales, and surf. The inactive phase of the MJO, exact opposite. It's like a high pressure system. It creates falling dry air, cuts off the flow of energy to the jet stream. The jet stream gets weaker, splits, and is not very well supportive of gale development. The two phases of the MJO, active phase is on one side of the planet, inactive phase on the other, and they rotate west to east around the equator. Active phase, or the inactive phase, takes about 4 to 6 weeks to make it from the West Pacific to the East Pacific. So during that time, as the active phase is lifting warm, moist air aloft, but especially when it's over the far West Pacific, that's when it's best for helping support gale development, primarily in winter months in the Northern Hemisphere, but also adding some degree of support for gale development in the Southern Hemisphere. And the same pattern holds true in the Indian Ocean and the Atlantic. The other thing is, because the active phase of the MJO is a low pressure system and trade winds are supported by high pressure, so the active phase of the MJO reduces trades on the equator, sort of cancels out the high pressure system. Likewise, when the inactive phase is in control, it's a high pressure system. Trades are generated by high pressure, so they sort of marry up and make trades stronger than normal. Using that bit of information, that bit of knowledge, you can then look at this data from the TAO buoy array, a series of buoys that are strung across the equator from west to east, used for monitoring El Nino, but there's wind sensors on those buoys, and these arrows indicate the speed of the winds and their direction. Anything out of the east is a trade wind. The longer the arrows, the stronger the trade. So as you can see, strong trades over the East Pacific, moderate to strong trades over the Central Pacific, and trades, but not blowing particularly hard in the West Pacific. Oh yeah, that's the date line right there. That's the equator there. That's New Guinea there. And Ecuador, this is just on the equator, 5 degrees north and south of the equator. That's all we care about. Ecuador would be off over here somewhere. But it's not the actual wind speeds that matter. It's the anomaly, the difference from normal for this time of year. Okay, and that's what these arrows indicate. So the trade's a little bit stronger out of the east here in the East Pacific. Maybe suggestive of the inactive phase of the MJO. But then you get here in the Central Pacific, Hawaii. Where's Hawaii? About 158 west, so right here. So Hawaii would be somewhere north of there, up at 20 north. Trades pretty much normal. Same thing in the West Pacific. Certainly not stronger than normal. So inactive phase of the MJO over the East Pacific, and maybe some sort of weak active phase over here in the West Pacific. Hard to tell. Let's dig deeper. So when we go to the GFS model, this chart depicts zonal wind anomalies. Now they're not at the surface. This is up at 850 millibars, up at about 4,700 feet. But a good proxy for what's going on at the ocean surface. And sometimes you can sort of tease out what's going on regarding the active and inactive phases from this. This is the whole plan on one chart. The date line runs right up the middle. We're going to focus on the Pacific, but if you live elsewhere, you can kind of guess, where to look and figure it out for yourself. Far West Pacific starts about 125 east, so right here. Okay, date line there. California is at about 120 west, and then Ecuador is over at about 80 west, somewhere here. So it is the West Pacific we're really interested in, right there. The blues are easterly anomalies, the inactive phase of the MJO, or stronger than normal trades. Plain as day. Oh, and here's today's date. You can see westerly anomalies over the maritime continent, that'd be Bali in that area, and easterly anomalies fully in control of the Kelvin wave generation area, the West Pacific, and forecasted to continue for the next, this is 2 weeks out. So inactive phase, clearly in control. We were hoping you see the westerly anomalies here back in July, the whole way through the month, and the models had all suggested westerly anomalies expanding over this entire area as we got to like today. And no, that's not happening. The models just completely botched the forecast. And if anything, well, you kind of know as we get in it, you'll see what's happening over the Central Pacific. But it is not looking like ENSO neutral anymore as we get into the fall and winter months. So here's a model that goes out 2 weeks. It's not doing the winds, though. It's forecasting outgoing long wave radiation, OLR. That's cloud cover. if you have the active phase of the MJO and it's lifting warm, moist air aloft, well, eventually, on average, that warm, moist air is going to condense and create more clouds than normal. Again, it takes weeks for the MJO to move across the equator from, right there's the equator, from west to east across the Pacific. So the oranges represent higher outgoing long wave radiation, sunlight reflecting off the ocean surface, clear skies, inactive phase of the MJO. Falling air would create, rising air. So this is falling air. Rising air would take warm, moist air, lift it aloft. So maybe that's suggesting where the active phase of the MJO is. Makes sort of sense given all the tropical activity right along in this area. So per the statistic model, and let's get ourselves oriented here. Equator right there, South America, Central America, Australia, New Guinea, dateline right there. So inactive phase of the MJO in control of the West Pacific today, 5 days from now, theoretically fading 10 days from now, and a dead neutral pattern 2 weeks from now, 15 days out. That's the statistic model. The dynamic model, the GEFS, that's the GFS ensemble model, says maybe the inactive phase holding for the whole next 2-week window, and a bit stronger than what the statistic model suggests. But 2 weeks out, there's that view. There's that view, a bit of disparity between the two models. Phase diagrams for the same two models. Okay, how do you read this thing? Well, the MJO moves west to east on the equator from the Indian Ocean to the maritime continent, over the West Pacific to the East Pacific, under the United States, across the Atlantic to Africa, then back to the Indian Ocean. The heavy dot is where the active phase is today, so over Africa. Okay, previous chart sort of made it look like it was in the East Pacific. It's more towards Africa. The further the dot is away from this circle, like if it were way out here, that would be a strong active phase. That's a pretty weak active phase. And 1, 2, 3 forecast members put it over in the East Indian Ocean 2 weeks from now, and exceedingly weak inside the circle of death. Basically, it's a no active phase at all. The dynamic model, basically meandering around a bit more, but painting the same picture with a weak active phase over the Indian Ocean for 2 weeks, or 2 weeks from now. So none of this is saying any hope or any help from the MJO, either now or over the next 2 weeks. That said, you see what's happening in the Southwest Pacific right now, and even in the Central Pacific. The MJO being weak, probably the inactive phase is equally as weak, and so it's not playing a super contributing role into swell development, which I think at this point is a good thing. Next up, 850 millibar zonal wind anomalies from the CFS model, a different model. This is the whole plan on one chart. Dateline runs right up the middle there. Far West Pacific starts 125 east, so over here, and then California about 120 west. But the main area is the West Pacific from 125 east to 170, so draw a box right in there. So you can see and this shows you the MJO, the solid contour of the active phase of the MJO, the dotted contour of the inactive phase, kind of broken up, kind of not. Model's having a hard time because the MJO is so weak, but you get the sense. Active phase of the MJO started developing over in the far West Pacific, 21st of June. It's continuing to make its way across the Central Pacific today, theoretically producing westerly anomalies. The previous model didn't show that, so there's a bit of a disparity here. Also notice when the active phase is in control. Notice the plethora of tropical storms or tropical systems that accompany it. Now, so here's today, West Pacific. Here's our easterly anomalies, all in control of the West Pacific, and forecast going for the next 1, 2, 3, 4 weeks. Strong active phase of the MJO building over the maritime continent. One would think that the South Indian Ocean is really going to light up and start taking control as this sets up. And it might be enough to start pushing some energy under Australia or under New Zealand into the far West Pacific as we get to the end of August. But right now, it seems, you see the dotted contour here and here, suggesting a weak inactive phase, maybe for the next 3+ weeks in the in the Pacific Ocean. So maybe not great support for storm development, but because it is so weak, that gives us a glimmer of hope. And then the CFS model going out 3 months, as some of you have mentioned in the comments, and I do read all of them. Yeah, you don't believe a model going out 1 week, and then you're going to show us a model that goes out 3 months and make us try to believe that? I go, no, but, it's kind of fun just to watch and see and tease yourself, I guess. So anyway, all right, 850 millibar zonal wind anomalies, past performance here, the forecast up here, the date line right running up the middle. Far West Pacific starts at 120 east, something like that. All right, so you can see the building. The yellows are westerly anomalies. The buildup of westerly anomalies in the West Pacific as of today. And according to this model, that's supposed to continue the whole way through for the next 3 months. But you also notice there's this dividing line right here that's not present there. East anomalies over the East Pacific, building and strong westerly anomalies over the far West Pacific, and sort of an indeterminate state somewhere in here. We'll have to see. Let's overlay the MJO here. So according to this, the active phase of the MJO is actually filling the entire Pacific as of today, and forecast to slowly be easing off to the east over the next mainly week, I'd say, week to 8 days. So probably a good shot at some continued storm development in the South Pacific while that happens. Then a weak inactive phase sets up. Westerly anomalies have been forecast in this area over the next 2, 3, almost 4 weeks. This model has now backed off and kind of fallen in line with the GFS model, just saying, nope, easterly anomalies in control. So I'd say this is going to be kind of a dead zone for surf development, at least in the Pacific, for the next 10 days out to about 3.5 weeks out. Then here's the big tease again, the active phase of the MJO. This model still won't give it up. In control, producing westerly anomalies going to, that is about 165 east, so filling the West Pacific for the next, well, almost 2 months. But again, that's a month from even starting to happen. So for the naysayers that say it's all not real, it's nonsense, probably a good position to have, not get your hopes up. Let's overlay the low pass filter here. So here's sort of what is going. Here's the balance side of that comment. The solid contour here, or that opinion, I should say. The solid contour, the low pressure bias. It has been, this is actual right here, been making steady inroads into the West Pacific, and as of today is reaching basically halfway across the Kelvin wave generation area. This is like the El Nino indicator. Last year or last fall, it was all confined over the maritime continent. Now it looks like it's sort of straddling the East Maritime continent and the West Pacific. And you notice even over the next week to almost 2 weeks, it's supposed to make a little bit more progress, filling half the Kelvin wave generation area. That is something I could believe as a realistic possibility, is seeing how it already has momentum going that way. But after that, you see it just locks down. So it's a split pattern. And the dotted contour here, the high pressure bias. Here was our La Nina last winter, 1, 2, 3, and it was only a Modoki La Nina. Then we get into, here we go, into October, 1, 2, 3 contours. But notice where it's centered at, like 130 east or 130 west, whereas last year it was on the date line. Now the issue with this is, well, if this is a high pressure bias and California is at 120, this suggests locking down high pressure over at least the southwestern tier states. Probably pretty dry conditions as we get into fall and probably even winter. So some sort of a La Nina pattern, and I'd probably call it a Modoki La Nina, but an eastward displaced Modoki La Nina, with something that I'm not going to call it a Modoki El Nino, but maybe something like that over the West Pacific. Interesting sort of pattern. And this model has been hinting at that now for a month or more, so something to consider. Subsurface temperature anomalies. And here's where we now move to the El Nino La Nina portion of the discussion. We're looking at data from the TAO buoy arrays. This is the East Pacific here, West Pacific here. The X's are the anchor lines, and the X's themselves are sensors on the anchor lines strung the whole way across the Pacific from the East to West Pacific, date line right there. These are temperature in centigrade. Okay, so the 29-degree isotherm, that's warm water. Last week's video is like at 180. It's backtracked to 175 east. 28-degree isotherm, I think it was at 160. Might have even been at 158 west at one point. Now it's at 167 west. Why is this warm water backtracking? Well, it suggests that there's trades blowing stronger than normal across this area. And then the 24-degree isotherm, last week it was like 104 west. Now it's at 110. Not even reaching into the Ecuadorian coast. Again, this trade wind pattern. Not the actual temperatures that matter, though. It is the anomalies, the difference from normal for this time of year. We have warmer than normal temperatures in the west, warmer than normal in the east, but in the past 2 weeks, the emergence of this cool pool has set up with 3 degree below normal temperatures here at, what is that? That's 140, almost 150. So south of Hawaii on the equator, right in the middle of the Nino 3.4 region. The models had been hinting at this, especially the CFS model. The other models, not seen it nearly as much, but you see now there's this break. You have cool, this is the neutral line right here, and it's building and reaching off to, where are we? Well, beyond the date line, there's this whole area here of cooler anomalies. You can just see this cool pool eventually erupting up to the surface somewhere here. If it doesn't move over this way, that would be more in favor of a Modoki La Nina. But if it starts filling in and building this way, cutting this out, then maybe that's some indication of more of a true La Nina coming. Hard to say. Too early in the game. Here's another chart using the same data, but also takes some satellite data, throws it into the mix. You can see the same pattern. If you have westerly anomalies in the west and easterly anomalies in the east, well, yeah, it wouldn't be surprising to see warm water pushing, well, over the date line. But here's that cool pool with 1, 2, 3, 4 contours. So that would be 1, 2, 3, 4. So 3 to almost 4, probably about 3 degree below normal anomalies in this pocket. Cold upwelling Kelvin wave, if you will. The last lingering bits of warm water off of Ecuador, my suspicion is that will be gone in a week or two. Here's the sea level data from, I think it's a Jason 3 satellite, but it could be a whole host of multiple satellites. They all measure the height of the sphere of the ocean, right? Take out the waves, the wind waves, the tide. Is the sphere higher or lower than normal? Why do you care? Well, if you have cold water at depth, it would typically contract. That would leave a divot on the ocean surface. Warm water would expand. It create a buildup on the ocean surface. And that's what this is measuring in centimeters. So South America here, that'd be Ecuador, that's the equator right there. Central America, date line right there. New Guinea is there, okay. Below normal anomaly heights, 5, 10, 15 centimeters, the ocean surface 15 centimeters lower than normal there, and 25 centimeters lower than normal there. Again, that's exactly where that cool pool we suspect is hiding. The exact amount of how far below normal, undetermined. But now we see, compared to last week, even cool anomalies starting to build off of Ecuador. And warm anomalies confined to the West Pacific. At some point, we'll see this sort of you'll get the sense of easterly winds blowing along here, confining the warmer than normal subsurface temperatures for the West Pacific and not allowing them to make it across the date line. Upper ocean heat anomalies over time. Here's the scale, goes back a year, West Pacific here, East Pacific here. Last year's La Nina with 1, 2, at least 3 pulses in this would be August, October, September, October, and December, January time frame. Our Modoki La Nina with all westerly anomalies in the far West Pacific. Trade sort of backed off somewhere here in April, May, June to early part of July time frame. You see warm water started pushing across the Pacific. But then right here, the suspicion is easterly anomalies are picking up. Here comes the development of the cool Kelvin wave, started about mid-July, and as of now is filling not a huge size area, certainly not anything compared to this, but we'll see what happens over the coming weeks and months. If easterly anomalies expand in this area, we could be looking again at something like this. Sea surface temperature anomalies. Okay, South America, Central America, New Guinea, the equator right there at 0, the dateline 180 west, are developing pool of cool anomalies right in the middle of the official El Nino monitoring region. They call it the Nino 3.4 region. Goes from 170 west to 120 west, 5 degrees north and south of the equator. You still see warm anomalies here off of Central America. That's supporting tropical storm activity, and you see a bit of it. Notice this here, but that is upwelling. This doesn't tell you the depth of the warm anomalies. It just says literally on, I don't know, 1 inch of the ocean surface what the anomalies are. You see cooking warm water here, but that is likely just high pressure, pretty typical for this time of year over the North Pacific. And in the center of the high pressure system, there's no air moving at all. It's just dead air. And so the sun beats, and there's no clouds. The sun beats down on the ocean surface, starts warming it up. So I'm not going to get too worried about that. That's upwelling from a tropical storm activity. This here is upwelling from our, again, if you have high pressure here, well, then your trades blow down the coast. You see the upwelling along the coast, and it slides out south of Hawaii. It's just the 5 degrees north and south of the equator that is really of concern. And the drop in water temperatures here and the assumed increase in trade winds in that area. Sea surface temperature trend for the past 7 days. Our water temperature is getting cooler or warmer. See pockets of cooling here. Out in the official El Nino monitoring region, pretty much neutral. This doesn't scream at me saying, oh, there's a major increase in trade wind activity. But we do know subsurface, there's a whole bunch of cold water sitting somewhere in here. So for the moment, not looking so bad. The alternate sea surface temperature anomaly chart, instead of using 30 years of past data, which is probably, I don't want to say polluted or corrupted, but it's biased by a warming planet signal. And so there's various strategies one can use to try to tease out and really say, well, what's the difference between normal and cooler or warmer than normal? This just says, okay, give me over the entire planet, what's the average water temperature, and then compare every sector, every grid square of the planet against that average. And this shows a clear La Nina sort of pattern, cooler than normal waters, and you can just see you had high pressure here, trades blowing that way, high pressure here, trades blowing that way. Would just carve all this out. But notice, not up along the coast here. So again, this sort of Madoki-like temperature pattern. This is relatively newer as compared to the old way of computing sea surface temperature anomalies, but just a bit of data to throw into the mix. And then the 2-week or 15-day sea surface temperature anomaly change. You see warming here again off of Ecuador. There's Ecuador with some pockets of cooling. Then you get out into the Nino 3.4 region. Right out in here, it's sort of a mix of cooling and warming. Nothing screaming La Nina, but nothing screaming neutral either. Probably a better index is this CDAS Nino 1.2 or 1+2 index. Just gives you, here's what the temperatures are in the Nino 1.2 region there, right there by Ecuador and the Galapagos Islands over time. You see today's value, 169 thousandths of a degree below normal. Okay, we were above normal. I mean, if you were to average this whole block out here in the Nino 1.2 region, you go, yeah, temperatures are normal, maybe even a little bit warmer than normal, but not markedly so. But it is the Nino 3.4 region. The official El Nino monitoring region on the equator, 5 degrees north and south from a point south of California out to about the dateline. Temperatures consistently have been below normal. We took a major hit here in the month of July. Temperatures dropped down to like 0.6 of a degree below normal. Today, 440 thousandths of a degree below normal. Now, let's be clear. Normal is considered anywhere from 0.5 degree above to 0.5 degree below. And in reality, a week or two, one way or the other, this still says ENSO neutral, but we biased a little bit cool, and we've gone a little bit cooler here in later July and early August. Nothing to get too particularly alarmed about looking at this. The only thing that really is a little bit of a concern is the building pool of cool subsurface temperature anomalies. And that's really the indicator of what's to come in weeks and months ahead. So let's go look at yet one other indicator, the Southern Oscillation Index, difference of pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific Ocean, Darwin in more or less the maritime continent. When pressure is lower in Tahiti relative to Darwin, the index goes negative. Hey, minus 19.6. That looks great. We're in the active phase of the MJO. Well, it's only 2 days of negative values. What's the trend been daily for the past month? Pretty positive for the most part. The 30-day average takes some of the noise out of these day-to-day variations. The value, 4.77. Where were we a month ago? We were about even. So if anything, this suggests pressure is rising over Tahiti in the Pacific Ocean. Okay, and you go, well, okay, the MJO, is like a 30 to 40-day oscillation that goes right over top of Tahiti. So that would influence that, and this clearly, the 30-day average, you can see that would be like the active phase. This would be like moving to the inactive phase. So let's go look at the 90-day value. That'd be more like an El Nino La Nina indicator. Today, value 3.4. Where were we a month ago? 1.75. I don't know that statistically that makes any difference. Let's go look at this on a graph. There we go. Here's the 30-day running average of the SOI. Today's value up here at, +5. Now, this is off by a little bit, the different ways of computing it, but you can see the trend. Here was our, and this says if you're below 7 or above 7, that's what they consider normal for the SOI. I like to use 5 one way or the other. Either way, the downward spikes, active phase, the MJO, the upward spikes, the inactive phase of the MJO. When the active phases are more dominant, the general trend line goes down like it did here in 23-week El Nino, if you will. Then we got into last year, August, November. They called it a Madoki La Nina, but I mean, looking at this, it almost looked neutral, just biased, weekly inactive. Here we are today for the past month or two, as neutral can get, maybe just biased on the plus side, so nothing too concerning. But then we have outgoing long-wave radiation anomalies. This is satellite-based. Are there more clouds than normal? The date line runs right up the middle. This is the whole planet. All we care about is the West Pacific Ocean, from 125 east to about 170 west. The positive values here, more sunlight, less clouds radiating off the ocean surface. Clear skies, that would be high pressure over the date line. That's your La Nina indicator. And this was last fall and winter. And then here was this building cloudy pattern that was starting to make its way into the West Pacific in May and June. And all looked good until right smack about the middle of July. Boom, it just shut off. And then here comes this building cloud-free pattern. The sea surface temperature anomaly thing, I wouldn't be so worried about, but then we got the cool anomalies developing subsurface, and now we're starting to see building clear skies over the West Pacific. 2 strikes. So then we go to the CFS version 2 model, sea surface temperature forecast from the Nino 3.4 region. This is the most aggressive of any of the other models. You can clearly see it here. A bunch of you have commented and worried about this dip here in sea surface temperatures. So July, we were basically neutral. You see just the downward spike. Not huge, down to 0.9 of a degree or 0.95 in November. For a month, that doesn't really matter. Over a 5-month period, so we're talking August, September, October, November, December, that smells of some sort of a La Nina. And this, if anything, is digging deeper, not getting shallower, suggests the model is more favorable for some sort of La Nina development as we get into the fall. Now, this is the raw data. PDF corrected. Okay, a little bit better. It shows temperatures down to 0.75 degrees. And let's be clear, normal is half a degree below normal to half degree above. So this is only saying that you're in La Nina territory for, let's say, October, November, and December. 3 months. Officially, you got to be in 3 or 5 consecutive 3-month overlapping periods, which this is using. This only says, at best, Modoki La Nina, not full-on La Nina. But then we go to the PDO data. This is not forecast. This is what is actually happening. The PDO, the Pacific Decadal Oscillation, it's like this long-running El Nino, La Nina sort of thing. Cool. When you see the blues, that's cool. It's effectively higher than normal pressure over the Pacific, La Nina, stronger than normal trade. So you can see, you can literally pick out from like, and it's not just short periods. You know, you can see there's a bunch of variation, but like between 1948 here and 1957, there was a long run of cool waters. Then it sort of was balanced out, but really this was a La Nina, or a negative phase, a cool phase of the PDO that ran from 1948 to 1976. Then you see positive anomalies from 76 the whole way to 98, culminating with the super El Nino of 97, 98. And since then, we have been consistently cool. Now, you can go back here and look at the record. I don't know how they got this data that goes back into the 1800s. I mean, yes, I do know. Ice core samples, tree rings, anything you can find. And, you know, it's an admirable effort. I'm not belittling it at all. It's science at its best. But, you know, the satellite era didn't even really start till somewhere around in here. But where I want to bring your attention to, here is the value from July, right there, -4. And those of you that follow the PDO, that -4, I dare you to find a reading of -4. It's right there anywhere else on this chart, going back to the mid-1800s. There's a 3, I'm not going to be able to hit it here, but there's like a -3.5 there, and there was a -3.85 there, or 6.5. This is the lowest PDO reading ever recorded, at least by NOAA's index. And to me, that with the building, you know, cool subsurface pool and easterly anomalies, it kind of sets the tone for maybe what's to come. The interesting part is the PDO is supposed to be a lagging indicator, not a leading indicator. So don't go, oh, that's the sign of what's to come. At least officially, the Southern Oscillation Index should have shown it way before the PDO did. So, you know, is there some weirdness going on here for 1 month for a 1 month of data on a cycle that typically lasts 25 years or so? I'm not going to get too upset about it, but it is kind of a little bit alarming. All that aside, a solid, long-running series of swell energy is pushing towards Hawaii and the U.S. West Coast. Like for the U.S. West Coast, a solid week of surf, probably starting a week from, so next week's video on Sunday will probably be okay, we got a whole week of surf coming. I would strongly recommend you make use of that. Also, Hawaii, it'll be like 2 days earlier, and it's not going to run quite as long because Hawaii's closer to the center of activity, but of course the surf would be more consistent. But there's a good window for late season southern hemi swell here in the Pacific, and I'd strongly recommend we make use of that. After that, looks like we're moving into the inactive phase of the MJO. Things will probably quiet down for a bit. Maybe not. We'll see. You know, the MJO is not a hard and fast rule, but just based, if I were to play the numbers in Vegas, that's how I would probably bet. Of course, I don't want to put 50 cents on it because I don't believe a model going out more than a week, but you get the general idea. Then theoretically, as we get into fall, supposedly a better, more active pattern, but I don't know. I'm losing faith in the models that far out. We'll have to see. Long term, yes, the PDO number is troubling. There are clear signs that some flavor of La Nina is trying to develop. Will it be a Modoki La Nina or a full La Nina? Well, we don't know. We'd have to wait till mid-August. I think it's the 19th of August when the consensus model comes out, and then we can see what all of them say. So the CFS model, the one we follow here a lot, tends to have a good leading indicator on what's going on better than everything else. So, keep that in your back pocket. So for right now, kind of looking like some flavor of La Nina as we get into fall and winter. Probably Modoki La Nina. So maybe last year's guess might be a good guide. That said, if the westerly anomalies continue to sort of push into the West Pacific, that might increase our favor or our odds for swell development over the winter, especially in the West Pacific. But it also, if the high pressure bias builds like what they're talking and it shifts to the east, that would put it smack over California. And that would definitely indicate drier conditions as we get into fall and winter. Some of you in the comments mentioned, Santa Ana winds over Southern California in the fall. I think that is a reasonable guess given the little bits of data that we have at this point in time. So take appropriate action if you need to. You kind of know what that means. I don't even want to say it. But, all right, so that's kind of it. We'll see how this all plays out. Surf coming short term, longer term, kind of a mixed bag favoring La Nina. That's a video for this week. If you enjoyed it, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. Comments, questions, always welcome. You notice as I read them, I try to, I take the threads that some of you talk about and weave them into these videos because they're all good comments and good insights. And, I'm not expected to know everything. You guys are smart too. You know what's going on. So I appreciate your input very much. Keep me on my toes. And other than that, let's see. And if you'd like to make a small contribution to the cause, always welcome. Hit the super thanks button down below, the heart with the $sign in it. With that, we are done for this week. We will do it again next week. Same time, same channel. Thanks so much for watching.